Unlocking the Power of Data Science for Predictive Modeling 2023. Predictive modeling is an essential tool in the field of data science for predictive modeling data-driven decisions. Building models that can forecast future events based on historical data is known as predictive modeling. This method is applied in a variety of contexts, including financial modeling, customer behavior prediction, and weather forecasting. Data.charism.info will examine the data preparation, model deployment, and model monitoring steps in the data science for predictive modeling in this post. Additionally, we discuss several complex predictive modeling issues, such as handling unbalanced datasets, model interpretability, and deep learning. Data preparation. Data science for predictive modeling is the first step in the data science process for predictive modeling. Data must be gathered, cleaned, and then explored to find patterns and relationships that might guide the modeling process. Data gathering is an essential phase in predictive modeling because the model's precision and applicability depend on the quality of the data. Internal databases, outside datasets, and web scraping programs can all be used as data sources. Data must be cleaned and pre-processed after it has been gathered to get rid of errors, inconsistencies, and unnecessary information. This may entail doing things like clearing out duplicate records, dealing with missing data, and standardizing data formats. Exploratory data analysis, EDA, is an important phase in the data preparation process since it sheds light on the properties of the data and aids in the detection of any biases or potential issues. EDA can include statistical tests like correlation analysis and hypothesis testing, as well as visualizations like scatterplots, histograms, and boxplots. Another crucial component of data science for predictive modeling is feature engineering. This entails turning unprocessed data into model-useful characteristics. Scaling and normalization, category encoding, and feature selection are some examples of tasks that might be included in feature engineering. The accuracy and effectiveness of the model can be increased by effective feature engineering. Model selection and training. Once the data has been prepared, the next step in the data science for predictive modeling is model selection and training. This involves choosing appropriate algorithms, splitting the data into training, validation, and test sets, tuning hyperparameters, and evaluating model performance. Choosing the right algorithm is a critical step in predictive modeling, as different algorithms are suited to different types of data and problems. Common algorithms for predictive modeling include linear regression, logistic regression, decision trees, and neural networks. The choice of algorithm will depend on factors such as the complexity of the problem, the size of the dataset, and the desired level of accuracy. Splitting the data into training, validation, and test sets is another important step in model selection and training. The training set is used to train the model. The validation set is used to tune hyperparameters and prevent overfitting, and the test set is used to evaluate the performance of the final model. The proportion of the data allocated to each set will depend on the size of the dataset and the complexity of the problem. Tuning hyperparameters is a crucial step in model selection and training, as it can significantly improve the accuracy and efficiency of the model. Hyperparameters are parameters that are set before training the model, such as the learning rate or the number of hidden layers in a neural network. Tuning hyperparameters involves selecting the best combination of values for these parameters to optimize the performance of the model. Evaluating model performance is the final step in model selection and training. This involves using metrics such as accuracy, precision, recall, and F1 score to assess the performance of the model on the test set. The choice of metrics will depend on the nature of the problem and the desired level of performance. Model deployment and monitoring. Once the model has been trained and evaluated, the next step in the data science process for predictive modeling is model deployment and monitoring. Model deployment involves deploying the model to production, where it can be used to make predictions on new data. Model monitoring involves monitoring the performance of the model in production and updating the model as necessary.